Hello everyone. In this video I will be solving some tangent line problems in different sections. In section 1, section 2, section 3 all we face some different types of tangent line questions other than the questions we solved in the previous lessons. So I collected the different types as one topic. So let's say the first type, let's say we have a function, a parabola, and there's a line, the tangent line, uh, that's passing through one point. So let's say this line, the equation of the line of this tangent line is y equals 4x minus 9, and the function here is f of x equals x squared minus kx. So if we know that we have a tangent line for a function, we will know that they are equal to each other at one point. There's a point of intersection, right? If two functions touch each other at one point, there's a point of intersection, so they are equal to each other at that point. So one of the steps might be equalizing those two functions. F of x equals x squared minus 9 in this question, and y equals 4x minus f of x equals x squared minus kx, y equals 4x minus 9. So they're like two different functions. We equalize them because they meet at one point. So this is one of the steps by solving these kind of questions, a tangent line for a function questions. One of the steps is equalizing those two things, those two functions. This will not enough for us to find the unknown. The question will ask us to find the unknown, the unknown letter. Either it will be in the line or it will be given in the function. We will need another step, another information. The thing is, we know that at that point, the slope of this tangent line is equal to derivative of that function, right? We have been studying that the slope means derivative, slope of tangent line means derivative of the function at that point. This is what we learned in the previous lessons. So we can use that information. Slope of tangent line equals derivative of the function at that point. One of the informations is not enough to find the unknown, so we apply another information, which is two functions are equal to each other at that meeting point. So we will use those two informations. We will find our unknown by using both of them. So first, let's equalize the derivative of tangent line to slope of tangent line to derivative of the function. With the slope of tangent line, it's written in slope intercept form, so it is coefficient of x, which is 4. So 4 equals derivative of the function. What is derivative of the function? Take its derivative. X squared's derivative is 2x minus derivative of kx is k. Okay, I have two unknowns. So when I equalize f and y, I'll also have two unknowns. So to eliminate one of the unknowns, I will solve the question by for either x for x for k. So I will isolate either x or k. It's better to isolate it for k. So I can put the value of k in terms of x. So k will be, when you bring k to the left, 4 to the right, 2x minus 4. Now, when I set the second equation by using this information, I will replace my k with 2x minus 4. So second step, equalizing functions. Equalize y to f of x. Your y is 4x minus 9 equals f is x squared minus kx. So I have many x's, only one k. So it's a smart move to isolate k, right? If I isolated x, there would be a lot of k's, right? 3 times. So isolating k is better. So in place of k, I will write 2x minus 4. Now, rewrite the equation. 4x minus 9 on the left equals x squared minus, distribute minus 2x minus 4, distribute minus to the bracket, multiply x by this bracket. So minus x times 2x minus 2x squared minus x times minus 4 plus 4x. right? It's a quadratic equation, so let's bring everything to one side of equation. X squared minus 2x squared negative x squared. When you move it to the left, positive x squared. 4 x's will cancel each other, and negative 9 to the right. So if x squared is 9, x is plus and minus 3. So I have two x values. No, now my goal is finding k. What was k? K was 2x minus 4. So since we have two x values, we will have two k values. So if x is 3, k is 2 times 3 minus 4, which is 2. If x is negative 3, your k will be negative 6 minus 4, negative 10. So we have two possible answers, 2 and negative 10. All right, so this is the way of solving these type of questions. This is second section question. Another question similar to this, same idea, and a mystery question. We have many mystery questions here. We have 4, 5 of them. All right, same idea. The first step would be equalizing the derivative of the function to slope of the line. Slope of the line here is negative 3 over 4 equals derivative of the function. Derivative of k over x is negative k over x squared. So isolate k. K will be 3x squared over 4, right? So second step, equalizing the functions. Since they meet at one point, they are equal to each other at that point. So function y, negative 3 over 4x plus 3 equals the function f, k over x. So in place of k, we will write 3x squared over 4. So in this case, left side will remain same, 3 over 4x plus 3. Right side, 3x squared over 4 over x. You flip. Keep the top, flip the bottom. The bottom is x over 1. When you flip it, 1 over x, multiply by 4 for x. Okay, now there's a cancellation, right? X and one of the x's will go. So here I see 3x over 4, negative 3x over 4 on the other side. Let's move this negative 3x over 4 to the other side. It makes 6x over 4 equals 3. Cross multiply. 12 is 6x, so x is equal to 2. This is not what I'm looking for. What I'm looking for is k. What was k? I isolated k as 3x squared over 4 in the beginning. Now in place of x, I will insert 2. So when you plug in 2 for x, 2 squared 4. 4 cancels, so k becomes 3. All right. So this is the first type of question you'll face as mystery question and an exercise question. The second type, this type is also common. This is first section question, and there are many mystery questions regarding to this. The tangent line to the graph of the function h at point 5, comma 2 passes through the other point 9, comma 0. Find h of 5 and h prime of 5. This is pretty simple. There is a tangent line that's passing through those 2 points. We're asked to find h of 5. So 5 is our input, x. We are looking for the output, y, right? This is our input. We are looking for output. So we are already given the point, 5, 2. 5 is x, 2 is y, right? If your 5 is x input, your y, your output is 2. So the answer is inside the question. It's given inside the question, no solving. Okay, just identifying, recognizing h of 5. When 5 is x, what's your y? Y is 2, given in the question. Okay, second question, h prime of 5. What does h prime of 5 mean? It means slope of the line. How do you find slope of the line when 2 points are given? by using y2 minus y1 over x2 minus x1 formula. It's pretty simple. So 2 minus 0 over 5 minus 9. So it's gonna be 2 over negative 4, which is negative 1 over 2 when you simplify. So that's h prime of 5. Okay, idea is simple. Another type, first section question. Suppose that f prime of c is 3. Find f prime of negative c in each case. If f is odd, if f is even. Okay. When f is odd, we are talking about f prime. What do you know about f prime? If f is even, what do you know about f prime? If f is odd, is f prime also odd? If f is even, f prime is also even. So this is the first thing you should figure out. If f is odd, let's say like x cubed, when you take its derivative, what would it be? 3x squared. So what kind of function now you have? You have an even function. The original function was odd. When you take its derivative, it becomes even. So if f is an odd function, f prime is even. This is the first thing you should know. If f is even, let's say you have some function like x squared, when you take its derivative, it becomes 2x, which is odd. It was even as an original function. When you take its derivative, it becomes odd. So if f is odd, f prime is even. So if f prime is even, f is even, f prime is odd. Okay, it's the opposite. Now, this is the first thing to do, first thing to know. So when you know this, you can answer the question easily. Part A. If f prime is even, then by changing sign of c with negative c, you'll get the same answer, right? The y doesn't change. When x changes, y stays same. You get the same result. If f prime of c is 3, f prime of minus c is also 3. So when you have even f prime, then the result is same 3. Part B. If f is even, f prime is odd. So when f prime is odd, then what is the relation? F prime of negative x being equal to negative f prime of x. So you get the opposite result. F prime of c was 3. When you get the opposite result, your result becomes negative 3. Right? So that's the idea. First, you should know what kind of function your f prime is, and then use the relation. If you have an even function at the end, you get the same result as the given one. Odd function, you get the opposite result. That's it. Okay. Okay, this was the third type. Fourth type of question, section 3 question. Determine when the slope of the graph is defined. Slope of the graph. This is about derivative of implicit equation. Slope means derivative, so we should take derivative of implicit equation. Okay, there are some other ministry questions and exercise questions too about this situation. So let's take the derivative of each one by one. Derivative of this product. Derivative of first 2x times second y plus first x squared times derivative of second, which is y prime, minus another product. Derivative of first 1 times second plus derivative of first times derivative of second, y squared derivative is 2y y prime. There's a minus in front. Here we have minus, distribute minus to the bracket. This is also minus. Okay, be careful. You suppose that when you open this, when you take derivative of this product, you put brackets. By distributing minus to the brackets, you get minus in front of each. So equals derivative of 4 is 0. Now collect y primes. Here we have y prime. Here I have another y prime. So take y prime as a common factor. Put the remaining inside the parentheses. X squared from the first factor, from the second, x 2y minus x 2y equals, let's send the others to the other side of the equation. 2xy, x squared y prime is on the other side, and minus y squared. This becomes y squared. This becomes minus x squared. Sorry, I already used that. 2xy. Let me clear this. Oh my god. I was supposed to do that. Okay, y squared 2xy. Okay, I think I cleared everything. I used that one, this one, this one. Okay, I am done, I think, with the clearing things. Now I need y prime alone, so divide both sides by x squared minus x squared y. Now, y prime is alone on one side of the equation. On the other side, we have this. So I see a fractional expression at the end. In order for this fractional expression to be defined, my denominator should not be 0, right? In order for a rational expression to be defined, denominator should not be 0. So you set denominator not equal to 0. This is the thing you need to do. So x squared minus x squared y is not equal to 0. Or you can take x squared as a common factor. X squared 1 minus y is not equal to 0. Or x squared is not equal to 0 and 1 minus y is not equal to 0, so y is not equal to 1. So like that. Okay, we are going to take derivative of each condition, isolate y prime, and at the end we'll have a fractional expression, so you set denominator not equal to 0. All right, okay. I made a mistake here, I think. It's not x squared y, it's x 2y. Okay, let me redo this again. Sorry. Okay, here I was supposed to write x squared minus x 2y, which is 2xy. Okay, now we set denominator, which is x squared minus 2xy, not equal to 0. So x squared minus 2xy is not 0. So when you take the common factor out, x minus 2y is not equal to 0. So you can say x is not equal to 0, or x is not equal to, x minus 2y is not equal to 0, so x is not equal to 2y. I think now it's true. Okay, another question. Let's take a look at some ministry questions. Find the value of k such that the function has a horizontal tangent line. You remember what horizontal tangent line is? Section 2. The derivative being equal to 0, right? If the tangent line is horizontal, its slope is 0. Slope means derivative, so equalize derivative to 0. Take derivative of this function, 3x squared minus derivative of kx is k equals 0. What's the value of x? It's given in the question as negative 1. So negative 1 squared 1, 1 times 3, 3, 3 minus k is 0, then k is 3. It's pretty simple. Another question, like section 1 questions. The tangent line to the graph of the function g at point 2, 5 passes through. We solved a similar question before. So this means if there are 2 points the tangent line is passing through, we can identify the slope by using those 2 points. And slope is already given as 4, right? So 4 equals, let's find the slope by using y2 minus y1 over x2 minus x1 rule. So 5 minus minus 7 divided by 2 minus a. So 4 equals 5 minus minus 7 is 12. 2 minus a, cross multiply. 8 minus 4 times 2, 8, 4 times a, 4a equals 12. 12 to the left, negative 4, negative 4a to the right, 4a, divide both sides by negative 4, a will be negative 1, so it is b. Okay, since it's g prime given, g prime means derivative, we find slope. Slope means this, by using that rule, we can find slope of 2 points, slope that's passing through 2 points. Okay, one last question. I think this question is the best question of this year, 2023 Ministry questions. If f and g and h are two differentiable functions and f is g over h, where h is not 0, find the result of f prime, knowing that g prime is this, and the tangent line is passing through those 2 points, like we did in this Ministry question and in the exercise question in the previous page. So, let's find the derivative of this first. What is f prime of x? Derivative of division, remember, derivative of top times bottom minus top times derivative of bottom all over square of bottom. Okay, now I need my x to be 1. So what I am looking for is f prime of 1, g prime of 1 times h prime of 1 minus g of 1 times h prime of 1 over g h squared of 1. So I need 1, 2, 3, 4 different information. So what are these? G prime of 1, h prime of 1, g of 1, h of 1. Okay, what is given in the question? Let's identify the given. We are given this. This is pretty smart. What is this? We studied this. This is first section. It is about definition of derivative. Remember, we used an easy way, a short way of identifying the limit. This limit case represents derivative, which gives you derivative of which function? Remember, your function is the first thing when you consider number plus delta x as x. So your function is f of x, g of x is 2x minus 3. What you need is g prime. So what is g prime of x? Take derivative of this, 2. So now we know that our g prime of 1 is equal to 2. What about g prime of 1? We can use the same. G of 1. We also need g of 1. G of 1 equals, substitute 1 for x, 2 times 1 minus 3, which is negative 1. So now I got 2 missing information. I got g of 1 and g prime of 1 by using this given. Okay. Another missing information would be finding the values of h and h prime of 1. So we are going to use that information now. What is that information? Here we have 2 points given. So for h, we are looking for h of 1 and h prime of 1. So for h of 1, the first point will give you the value. If your x is 1, your y is 4. It's obvious, clear on the point. H of 1 equals 4. No need to do anything. It's already there, crying out to be here. And h prime of 1, you take derivative of h by finding slope of the line that's passing through 2 points like we did in the previous question. So let's find slope of this line that's passing through 2 points by using y2 minus y1 over x2 minus x1. So 6 minus 4 over 3 minus 1, which will give you 2 over 2, which is 1. Now there's nothing missing. We know everything. So let's plug them back into the derivative of f. So now f prime of 1 equals g prime of 1, which we found as 2, times h of 1, which is 4, minus g of 1, which is negative 1, times h prime of 1, which is 1, divided by h squared of 1. What was h of 1? It was 4, so you square it. So I think I'm almost done. 4 times 2, 8. Negative, negative, positive, 1, 9. Over 4 squared, 16. Okay, this is the smartest question that has been asked this year. We used many information to find the answer. All right.